vertical asymptote versus a hole in the graph. So first things, both a vertical asymptote and a hole in the graph represent x values that are not defined in the function. So you may remember that if you have a graph and you have a vertical asymptote is a line where the graph will approach but never touch. So it's kind of a barrier within the graph. Now a hole is if we had a graph and then a hole, it's really, you would see, kind of just a big, it's a hole in the graph. It means that the x value here is undefined, but the graph kind of goes through that point. So let's look at a question here. Consider the function f of x equals x plus 2 over x squared minus x minus 6. We're going to identify any vertical asymptotes or holes in the graph. First off, when you have a rational function, if you look in the denominator, we can see that x squared minus x minus 6 can be factored. So let's go ahead and rewrite this in factored form. So x squared minus x minus 6 factors to x minus 3, x plus 2. You might notice right away, hey, I have the binomial x plus 2 in the numerator and in the denominator. So I can simplify that to just be 1 over x minus 3. If we are graphing these, they would look the same. Okay? The difference is whether we have asymptotes or holes. So when you have your rational function and you simplify it down, the simplified version, when you look at the denominator and say, okay, what's going to make this denominator equal to 0? Well, that's x equals 3. Because that is a simplified version, that is a vertical asymptote. Okay? If we go back to the original, you notice in the original, our denominator has undefined pieces as x equals 3 and x equals negative 2. Both of those are undefined based off of our given function. Well, we know because after our simplification that x equals 3 is a vertical asymptote. The piece that is simplified out, so the x plus 2 that was in the numerator and the denominator, because that's simplified out, x equals negative 2 will be a hole in the graph. It's a hole because x cannot be negative 2. If x is negative 2, then our function is undefined because we will have a 0 in the denominator. But the graph is going to go through that point, and therefore we make a little hole in the graph. So if we look at this graph, okay, you will see that at x equals 3, there is our vertical asymptote at x equals 3. And then at negative 2, you can see that we have this hole in the graph. So the graph, on the left side of the asymptote, it goes low and it comes, but when we get to that negative 2, it doesn't exist. So that's where the hole is, and then it continues on. That's the idea of hole versus asymptote. An asymptote means the graph will approach but never touch. A hole in the graph simply means we kind of have a jump, right? We continue, we jump over that spot, and we continue on. So that hole just gives us a little break in the graph, if you will. So that's the difference between an asymptote and a hole, and how you can find that based off of the given function. Remember, if you simplify it out, it's a hole. If it's there after simplification, it is a vertical asymptote.